Okay, when we left off, we were talking about section 3.2, so we did a few of the examples, but not all of them. So I wanted to go back and do the examples we missed. So we learned the substitution method and the elimination method. Have you guys all done the homework so far? Yeah, was it pretty easy? Yeah, a lot of times when I grade this homework assignment for substitution and elimination, there's a lot of simple mistakes that lead to terrible, terrible errors. So you guys will have crazy decimal answers instead of the nice whole numbers that I gave you. So just be very careful on substitution and elimination to make sure that you're working through each step to get the correct answer. Okay, so number one, we have y equals x, and then x plus y equals 4. So if you remember when we talked about substitution, we said always solve for one of the variables. So in this case, we actually have y equals something, and we also have x equals something. So it doesn't matter what we do. I'm going to go ahead and take y and replace it with x in the second equation. So I have x plus x equals 4. So 2x equals 4, so x equals 2. Then once you have one of the values, go back and find the other value. So we have x, find y. So y is equal to x, so y is also equal to 2. And then remember, I want your final answers written as a point. So if you didn't do that on your homework, make sure you go back and write it as 2, 2. So 2 for x, 2 for y. Okay, we did number 2 and 3, correct? All right, the elimination method that we did, I think we only did one of these. Which ones did we do in your class? We did all of them in your class? Oh, okay, maybe you guys tried them on your own. So let's go ahead and look at this one just as a review. So number 3, if I multiply through by a 2, I'd have 10x minus 4y equals 38. That way, my bottom equation has positive 4y, and my y's will cancel, which is what you want. So one of your variables to go away. So then you get 13x equals 39. So x is 3. And then you go back and plug in. So you get 3 times 3 plus 4y equals 1. So that's 9. Subtract the 9 over. So I get 4y equals negative 8. So y is negative 2. So you got 3 and negative 2. Okay, you guys remember all these? Easy enough. All right, so now let's try the trickier ones. So these are the ones that we didn't get to last time. So solve the systems by any method. So number 1, I have 2x plus 2y equals negative 1. This looks like it's going to be pretty easy to set up in my elimination form so that I have my x values, y values equal the number. So I'm just going to add my 4y over. So I'm going to have 2x plus 2y equals negative 1. 4x plus 4y equals 5. And I want to eliminate one of the variables, so let's say I want to get rid of my x's. I'm going to multiply through by negative 2. That's a negative 2. So then when I add straight down, I'll get rid of my x's. So my new equation is negative 4x minus 4y equals positive 2. And the other one stays exactly the same. So 4x plus 4y equals 5. So when I add straight down, do you guys notice something weird about this one? Yeah, both of them cancel. So I get 0 equals 7 when I add straight down. What does that mean? Right, it's no solution. Okay, so this is what we would call an inconsistent system. Basically, we have 2 lines, and they never intersect, so my 2 lines are parallel. So my 2 lines would be parallel in that case. Okay, number 2, when you guys see it, some of you guys probably have a little bit of panic, so fraction phobia. You guys see that you have lots of fractions. So the easiest thing to do to start this one out is maybe just clear the fractions. So if I just want to clear the fractions to start this one out so it's not so scary looking, the top one I'd multiply through by 12, because that would be what I would change my denominators to, right, my common denominator. And the bottom one I'd multiply through by 10. Okay, so my top equation, when I multiply the 12 into every single thing, I get 12 times 3/4, so if you need to do it off to the side, you can. The 12 and the 4 reduced to 3. 3 times 3 is 9. So you'd get 9x plus, the next one is going to be 12 times 2/3. So 12 and 3 reduced to 4. 4 times 2 is 8, so 8y equals 84. And then the same thing for the next ones. So now multiply the second equation by 10. So 10 times 3/5, the 10 and 5 would reduce to 2. So you get 2 times 3 is 6x minus 5y equals 180. Okay, it's not really that nice for us right now, because when I add straight down, my x's won't cancel, my y's won't cancel. But it does look better than it did. There's no fractions. Okay, so now we need to go ahead and do the substitution method. So let's maybe change the x's so that they're both 18. So one's 18, one's negative 18. See how that's a lot easier than multiplying by 5 on top and 8 on the bottom to get rid of the y's. We want the smallest numbers as possible. Okay, so I'm going to multiply my top equation by 2 and my bottom equation by negative 3. So that way I'll have 18 on top and negative 18 on the bottom. So my top equation is now 18x plus 16y equals 168. And my bottom equation is now negative 18x plus 15y equals negative 540. What did it get? What? 18, not what? Okay. All right. Add straight down. $372. And it's negative, right? All right, and then do negative 372 divided by 31. 12. So negative 12. All right, so y is negative 12. And then once you have y, go back in and plug in to find x. Now you can plug into any equation you want. If you really don't want to deal with the fractions, you can use one of these new equations that we had. If you don't mind fractions, you can deal with the fractions. It doesn't matter. So let's say I go back and I plug into the top equation. So I'd have 3/4 x plus 2/3 times negative 12. That equals 7. Well, 2/3 times negative 12, the 3 and the 12 reduce to negative 4. So I get negative 8. I'm going to add my 8 over. So I get 15 on the right side. How do I get rid of 3/4? Multiply by 4/3, thank you. So I get x equals 4/3 times 15. My 15 and my 3 reduce to 5. 4 times 5 is 20. So that means my new point is 20, comma, negative 12.
Could you also plug it into one of those?
Yep, you can plug it wherever you want to. So if you don't like the fractions, you can plug it into 9x plus 8y equals 84, or 6x minus 5y equals 180, or like you're saying, the 18x ones. I usually try to find the ones with the smallest numbers, though, so it's not as hard to multiply. Okay, so 3.2 makes sense so far. All right, so let's try a story problem. So it says, last year the soccer team paid $5 per pair for socks and $17 per pair of shorts for a total of $315. This year they spent $342 to buy the same number of pairs of socks and shorts because the socks now cost $6 a pair and the shorts cost $18. Write a system of two equations that represents the number of pairs of socks X and the number of shorts Y bought last year. Okay, so let's talk about last year first. So I bought X pairs of socks. So that means I paid 5X just for socks, because they were $5 per pair. I bought Y shorts. So that means that I paid 17Y for all of the shorts together. This gave me a total amount of money of $315. Okay, the next one is 6X plus 18Y, and that equals 342. Okay, that's my system. You don't have to draw the brace there if you don't like to draw brace. B, how many pairs of socks and shorts did the team buy each year? So go ahead and try to solve this one. So use your calculator. Go ahead and try to solve. So what did you guys do to solve this one? Elimination. Did you multiply by 17 and 18? No. You went with the smaller numbers, definitely. Okay, so you're going to multiply the top equation by 6 and the bottom one by -5. Or you could do -6 and +5. It doesn't matter. So when you do that, you get 30x plus 102y equals 1890. Then you have -30x minus 90y equals -1710. So when you add straight down, you get 12y equals 180. So the x's go away. That means y is equal to 15. And now you go back and you find x. So you can plug into any equation that you want. So let's say I do 5x plus 17y equals 315. I have 17 times 15. Seventeen times 15 is 255, so subtract that over. So you get 5x equals 315 minus 255, so 60. So x is 12. So that means they bought 12 pairs of socks and 15 pairs of shorts. So that's your answer. All right, in the last little bit, it says, notice that in the previous problem we had an inconsistent system. Okay, so that was number 1. There was no solution. Okay, this happened when you had something like 0 equals 7, 5 equals 6, etc. So two numbers equaling each other, but they don't actually equal each other. So if that happens on your homework, write no solution. We've also seen a system with infinitely many solutions. Okay, this happened when you had something like 0 equals 0, or 5 equals 5, or maybe 2x plus 3 equals 2x plus 3. So the exact same thing on the right and left. On your homework, write infinitely many solutions. So some people in the other class were saying, well, why can't I write all real numbers? If you write all real numbers, that's okay. I'll accept that. But what that's saying is that basically, do you guys remember when you had infinitely many solutions, it was basically the same line. So let's say a point was 2, 3 on that line, and that was a solution. When you say all real numbers, it's kind of saying that every point in the whole plane is a solution. So that means that this point down here would kind of look like a solution. So maybe like 2, -5. Okay, and that's not a solution. It wasn't on the line. So when you guys say all real numbers, it's kind of implying that every single point is a solution, which it's not really. It's only the points that are on the line. So the best way to say it in these types of questions is infinitely many